Hello, hi, namaste. This is Surabhi, your chemistry master teacher at Vedantu. Welcome to this session where I'll be teaching you some super tricks to remember periodic trends. So before getting into the session, so what are these periodic trends? We all have realized the importance of periodic table, right? So there are so many videos on how to remember the atomic number, how to remember the periodic table, group wise, period wise, and everything. So every element has a set of properties. So how does these properties vary along the group and along the group across the period is what are periodic trends. So today we will be learning about very important periodic trends with lots of fun and super tricks and Menti. Are you all ready? You all can hear me, right? Yes or no? Okay. Hello everyone. Hello, hey Sweta. Hi, Oreo milkshake. Hey Srilata. Hello everyone. So ready? It's a different session, Kirti. We have done on the mnemonics, right? Yes. Hello. But before we start, I have two questions for you. So why don't we all go to Menti and try whether you can answer those questions. Are you ready? Yes. Oh, that's so sweet. Ready? Chal. So I will take you to Menti. Just give me a minute so that I can present it. Acha, we are here already. Cool. Can you see? So everyone go to www.menti.com and use the code 10360562 so that you will know the difference, how important learning periodic trends is. So if you will be able to answer, few won't be. They will be confused, but by the end of this session, I'm sure everyone will be able to answer all the questions which is in the Menti. So after learning periodic trends and super tricks to remember it, we will have one more Menti. So using the same link so that your points will be added on. So do not leave the Menti or the session. Stay back till the end. Now come on. Yeah. Good afternoon everyone. Hello. Hi. And as you all are joining Menti, let me tell you, make sure to hit the like button, subscribe to the channel and share this video with your friends because you know how important it is, right? Purple hearts, thank you so much, Suchi. Joined. So I'll just wait for another two minutes so that everyone can join. I know you will have lots of you have been saying that you have sessions at 3 p.m. but the students who are watching the video once the live streaming has ended, so do not worry, you will be also able to learn. So what you can do is you can just go through the questions and let me know the answer in the comment section. That's all. Yes, I do. I'm so sorry for that. Can you hear it? My sister is cooking. I'm really sorry. I guess it's over now. Yeah. So I have to eat after the session. You all had lunch. Why should she cook for you all? I don't know how to cook, so she will cook for me. Hey, yay, Tanner, welcome to the session. I mean, to the channel and everything. Are you ready? Shall we start? Hanji? Okay, then all the very best. Okay, so we have 7 questions in total, but 2 I will show it to you at the beginning of the session, and uske baad we will learn some tricks so that we can come back to the Menti and try to answer those questions based on what we have learned. Ready? Yes. Okay. Chal. And if you have not joined it, please go to www.menti.com and use the code 10360562. Which of the following increases down the group? Atomic radius, electronegativity, ionization energy. Even if you are not able to answer, don't worry, because by the end of the session, you will be able to. Your burger. Okay. Hey Purata. Hello everyone. Hi Harini. SPDF. Okay. See, periodic trends and the orbitals are different. See, let me take a screenshot of this. Okay. Let me take a screenshot of this. I have taken a screenshot. After teaching you the super tricks, we'll just compare. How many of you gave the right answer? Okay, shall we do that? Yes? You got a different question? How is that possible? You got a different question? How is that possible? But I can see only this one. Okay. Again, Menti has some issues. Let me just check what is happening. How? Everyone should get the same question. This is the first one. Yes, correct only. You have applied the same Menti code, right? 10360562, है ना? Right. How come? But I can see the same question. It's not possible. So what's the coupon code? Menti code you have applied. Is it 10360562? Yes. Let me just refresh it once. Let's just check. Okay. Yeah. So I'll just present it. Let's check now. You already have joined? Okay. Hey, that's okay, that's okay, that's okay. You all got the same question. Only I was able to see a different one. Is it? Arre? Is this some kind of magic? How is it possible? Okay, chalo. Hanji, ruko. Let's see. Oh, yeah. The modern periodic table contains. Oh, what is this? So most of you answered it right? Oh, 80% of you. That's nice. Come on, give me a high five. Why could I see a different question? You got this. Okay, cool. Got it. Okay, let's see next one. I hope it will be same for both you and me. Ma'am, dance. Why should I dance? You have to dance. 80% of you gave the right answer. That's nice. On the leaderboard, we have Kushi, Sansi, Aradhana, Sriya. Last bakery, please don't call me bakery. Even on long-term batches, they have started calling me bakery. I'm like, how do you know? Hare Krishna, Tanishk, Anna, Annie, right? Ted, Paki. If you have not changed your name, please do it. If you are okay with the same, then fine. Okay? Acha, that's you, Manaswini. Okay, cool. So question number 2. Just tell me whether it's the same or not. Okay? How many groups and periods are there in the modern periodic table? Is it same? The question, is it same? Yes, all of you. 18 groups and 17 periods, 8 groups and 17 periods, 8 groups and 7 periods, 18 groups and 7 periods. Same? Yeah, we did it, people. We did it. Come on, 3, 2, 1, and time's up because this was easy peasy, right? There are 17 periods? Huh? Every one of you have, and us, we are trying so hard to remember those 7 periods, and you have added 10 more. So after Mendeleev, I'll add all the 8 students ka name. Aapka naam batao ji, please. All the 8 students who said, ma'am, there are 17 periods. Come on. No, I'll try to add your name, okay? Come on. Me, you are all so proud, see, of choosing the wrong option. See, that is the reason you have to read all the options. I'll take a screenshot of this chat as well. Okay, not you. Okay, cool. So on the leaderboard we have Khushi, Aradhana, Hari, Sriya, Manaswini, Suchi Mama. Thank you. Areen, Mithil, Sunsi, Sebastian. Very good. So now what we have to do is, let's learn about the super tricks. Do you know any super tricks to remember periodic trends? Because whenever I was learning the periodic trends, it is thoda sa confusing, right? There are so many. Ionization, enthalpy, electron affinity, electronegativity, valence, electron, atomic size, metallic character, non-metallic character, electropositivity, electronegativity. How to remember all this, right? Difficult, or easy? Okay, but let's try to make it easy because that's what we do on this channel, isn't it? Yes. So super tricks, do remember periodic trends, but do not worry, I will be explaining each and every property, and then later only we'll explain the trend. Okay, how does it vary? Chalo, please start the Menti. Ho gaya ji Menti, Akshay. You need to wait for another like 15 minutes. So everyone, welcome to the session. If I have not welcomed you to the session, hello, how are you? What's up? Okay, so make sure to hit the like button, share the video, and subscribe to the channel if you have not done it yet. Thank you in advance. So periodic trends, I have told you what are periodic trends, isn't it? So everyone knows, kind of. Are you ready? Yes or no? You remember my explanation? Acha. Acha. Oh, that's nice. Very. Ready? Shuru kare? Come on, give me IFF. Let's go. Okay. So this is how the periodic table looks like. I hope you have not forgotten. Yes, you remember? If this is periodic table, everyone knows? You have seen it? Or this is the first time? So this is period, okay? The horizontal rows, they are called as periods, and the vertical columns are called groups. So in chemistry, it is very, very important, okay? Who is that? Who? Who is who? This is me. It's okay, Priyanshu. We will make it easy for you as well, okay? So the horizontal rows in the periodic table, they are called as periods, and the vertical columns are called groups. We have 7 periods, 1, 2, 3, 4, 5, 6, 7. So this lanthanides, actinides, they are in the 6th and 7th period only. Okay? So that's all. So do not count this as 8, 9. At least this is okay. Someone chose 17. Wow. And then you have 18 groups. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 18. Yeah. And then this is called as S block. A hai hamara P block. This will be D block. And A hoga F block, because the electrons will be added to the S block in these two groups, and here D block will be filled, and then P block, the electrons are being added to the P block, and here F block. That's the reason we have 4 blocks in a modern periodic table, and more than 80% of you gave the right answer in the Menti. So good job everyone, good job. Okay. So 6th and 7th. 6th and 7th are the longest periods. So first period is the shortest one. Okay. Yes. So now let's start with valence electrons. So what are these valence electrons? So it is very, very important, right? Even when you are learning about chemical reactions, metals and non-metals, acids, bases and salts, carbon and its compounds, you pick any chapter, even in 11th grade, this valence electron plays a very important role. Have you realized that? Yes or no? How important it is to learn valence electrons. So that is the reason we always start with learn atomic number and then electronic configuration, so that you will know number of electrons present in the outermost of shell. Based on that, you can tell the valency, and then everything depends on the valence electrons. What kind of compounds an element forms? How many electrons will it lose or gain or share? Whether it will be an ionic compound or a covalent compound. Is it ready to form coordinate compound? Everything depends on the valence electron. So it is very, very important. Let's start it from the valence electrons. So how do you define valence electrons? The number of electrons present in an outermost shell of the atom. So we already have learnt about shells, right? The Wu ma'am also have taught you. KLMN shells we have, and we know the reason also why it has started from KLMN, not ABCD. If you have not watched the session, please watch our Tuesday ka session, where we have taken this doubts from the students. We have answered that question as well. Now, if you can see, the electronic configuration of sodium is 281. Yes, 281. So, there is one electron present in the outermost shell. This will be the first shell will be K, and then L, and then M. So, M hoga the last shell, outermost shell. So how many electrons are present in that outermost shell? So that will be called as valence electrons. So for that, you just have to know the electronic configuration, and for that, atomic number, bus. Okay. So how does these valence electron vary across the period and down the group? See, if you go back to the periodic table, hydrogen's atomic number is 1, and then helium, and then lithium, beryllium, boron, carbon, nitrogen, oxygen, you have it. So the atomic number is increasing, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I take the first two periods. So what happens? First 1, and then 2, and then 2, 1, right? In the second period, then 2, 2, 3. So what is happening to the number of valence electrons across the period? It is increasing. Isn't it? Yes. So the number of valence electrons increases across the period. Neon has 8 electrons in its valence shell, whereas lithium has only 1. So across the period, what happens, children, to the valence electron? Increases or decreases? Come on, let me know in the chat section. Fatafat se. See, valence electron is, okay, you have 1, 2, okay, can you see if I write here, everyone? Let me use a different colored pen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the electronic configuration is 1, 2, and then 2, 1, 2, 2, 3, 4. This is carbon, nitrogen, oxygen, fluorine, neon. So what is happening to the number of valence electrons? Only look at the last shell, people. Last shell increase हो रहा है या नहीं? Yes, पक्का, पक्का, no doubt in that. Yes. See, I'm teaching you this now 2, 1, 1, 2, 3 also. Even if anyone is from first grade, you can still watch our videos. Increases पक्का. चल. Then what happens down the group? Does it decrease or remains the same? What do you think? Before I show the slide, tell me. Increase, decrease होगा या it will remain the same? Yes. Valence electron increases across the period. That is when you move from left towards right, the valence electrons increases. What happens to the valence electron when you go down the group, along the group? Okay. So it is same, right? Yes. So valence electron down the group, it remains the same. Why? So group number is actually equal to the number of valence electrons. If you take the first group, sodium, potassium, lithium, they all have 1 electron in their valence shell. And take 13th group, they all have 3 electrons in their valence shell. 17th group, they have 7 electrons. So here, please leave about the D block, okay, ignore D block. S block and P block mein, so first 2 electrons, 1, 2, the number of valence electron will be equal to the group number, and then from 13th, so if there are 3 electrons in its valence shell, then you need to add 10 to it. So 13th group, 14th group, 13th group will have 3 valence electrons, 14th will have 4, 15th will have 5, 18th will have 8. Yes? Right? Okay. Yes? Got it? So chemical bonding we have already started. So one standalone is done. So we will be coming up, I will be covering hybridization and the molecular geometry, everything. Yes. Okay, you want me to explain again? See. So valence electron, it remains the same in the group. As what happens is the number of shells, okay, it is increasing. So in first there will be 1 shell, and then in the second period there will be 2 shells and 3 shells. So but the number of electrons which is present in the valence shell will be same in all the elements belonging to the same group. Yes? Okay. Got it? So valence electron increases across the period and remains same in the group. Now what is this valency? See, valence electrons and valency are different. Please do not get confused. Valence electron is the number of electrons present in the outermost shell. That's all. And when it comes to valency, okay, so you have these many electrons. How many more electrons do you need to get that octet configuration? Or how many more electrons should you lose to get the octet configuration. So that is what is valency, the combining capacity of an atom. For example, let's take sodium 281. I'm sure you all know how obsessed I am with sodium. So it has one electron in its valence shell, but if it loses this one electron, it will have a stable electronic configuration. So sodium's valency will be 1. In the same way, let's talk about aluminium 283. It has 3 electrons in its valence shell. So if it loses those 3 electrons, again it can attain the stable configuration. So this is what is valency. How many electrons needs to be lost or gained in order to attain the stable electronic configuration. But how does it vary across the period and down the group? So across the period, I'll tell you. Down the group, can you tell me? Yes. Down the group, what will happen? Hello everyone. You're still saying hi only. What happens? Down the group. Yeah, man, that's nice. Same, okay. Very good. Because see, how does the valency vary? I'll tell you. Okay. So now we know how does the valence electron vary. So it is 1, 2, 3, 4. The number of valence electrons are increasing. First 1 to 4. With increase in number of valence electron, for 1 to 4 electrons, the valency will be same. That is, how many valence electrons are there? That will be the valency. Okay? So in sodium, there is 1 valence electron. So valency hoga 1. In calcium, there are 2 electrons in its valence shell. So its valency will be 2. But nitrogen ka electronic configuration is 2, 5. It has 5 electrons. Do you think it has to gain 5 electrons or lose 5 electrons, children? Let's go with the definition. Do you think nitrogen needs to lose 5 electrons or gain 5 electrons? Yes or no? Yes or no? Gain 5 electrons? No. My question is, the number of valence electrons are 5. Do you think it has to gain 5 electrons or lose 5 electrons? No. It needs 8 electrons. It already has 5. It is in need of 3. So the valency will be 3. But how will we know? If the number of valence electrons is greater than 4, if the number of valence electrons are greater than 4, then what you have to do in order to calculate or determine the valency is subtract the number of valence electrons from 8. Subtract the number of valence electrons from 8. So with the across the period from left to right, first the valency increases because it will be 1, 2, 3, 4. And then it starts decreasing. 3, 2, 1, 0. Don't I sound like a PE teacher? 1, 2, 3, 4. Hai na? Okay. So across the period from left to right, first the valency increases as there is increase in the number of valence electrons till 4. But after that, what happens? The number of valency, it decreases to 0. So I'll write 1, 2, 3, 4. 3, 2, 1, 0. You can actually check. Yes? Right? Got it, everyone? So atomic number, Ravindra, that is the basic, dear. You cannot look for a trick to learn atomic number. So along with the periodic table, hydrogen is 1. You should know. Calcium is 20. You should know that. Yes? Clear? Or more like a dance teacher. Exactly. 1, 2, 3, 4. Get on the dance floor. Now go back to 3, 2, 1, 0. Okay, so valency down the group, it remains same. There won't be any change. Why? Because the number of valence electron is same. Group 1 may all the elements have 1 electron in its valence shell. So the number of valency also, it remains same. Clear? Yes, everyone? Okay. That's nice. Okay, now we have another properties which has a particular trend, right? Which increases, decreases across the period, down the group. Let's try to understand. So to make you understand the periodic trends, we have 2 guests today. Who are those? Do you want to know? So they are Amy and Einstein. Whoa! Let's welcome them to the session, everyone. Let's welcome them. So Amy and Einstein, they are here to make you understand how does the remaining properties vary across the period and down the group. Who are they? I know, right? Let's welcome them. Pakka. Ha. Oh, see Amy. Hello. So Amy में A stands for atomic radius and M is metallic character. So let's see what Amy does to teach us how does the atomic radius and metallic character vary across the period and down the group. You thought some... Welcome. Yes. So what is this? But before looking at the trend, it is very important for us to know the definition, right? So what is atomic size? So the distance from the center of the nucleus and the outermost electron is what is known as atomic size. So obviously with the increase in number of shells, the atomic size also increases, right? Yes. How do you define atomic size? It is the distance between the nucleus and the outermost shell or electron. That is what is atomic size. And what is this metallic character? So how easily a metal can lose electron? Okay, so it is like sometimes some people are like, you want, take it. But few are like, no, I won't give you. You know, when it comes to especially siblings and all that, sharing things, there will be always one sibling who will be ready to give, right? No matter what you ask for, money or the clothes or the shoes or everything. But there will be one who is not ready to give. So that is what is. So metallic character is with what ease a metal atom can lose electrons. So metallic character zyada hai matlab it can easily give electrons and form a positively charged atom. Okay, same, even I have, Kriti, even I have. Okay, what is, why that's all? We can't just call someone AIM, right? So we have Amy. It's you, Sujay. You do not share clothes? Or do you do? You do or you do not? Same here. But I give clothes only to my sister, no one else. So first, Amy likes to stand straight. Everyone likes to stand straight. Okay, so meet Amy, everyone. Oh, that's a nice snowman. Okay, or snowwoman. We don't know. So Amy, she likes to stand straight. She or he or they. That means, so what is happening to these two characters? Atomic radius or size and metallic character. Just look at this. So this is smallest, medium and largest. That is atomic size and metallic character. It increases down the group. Look at the size. First it is smallest, then medium and then largest. Right? So the atomic size and metallic character, it increases down the group. Got it? That is why. Now the question is why. We know how it is varying, but now let's know the reason why. So first, in atomic size, when it comes to sodium, potassium, let's take it. So sodium ka electronic configuration is 281, right? It means it has 3 shells. Yes, people? Do you agree? It has 3 shells? Yes? Okay. है ना? 281. Whereas what is the atomic electronic configuration of potassium? Electronic configuration of potassium? 281. Very good. So sodium has 3 shells. Whereas potassium mein you have 4 shells. So which has greater size? You tell me. Which has greater atomic size? Potassium or sodium? Potassium, right? With the increase in the number of shells, atomic size also increases. What happens is this nucleus, na? It is like that. What Indian, the Hindi soap operas mein or soap mein you can see, right? How the mother-in-law wants to control everything in the house and all that. Thun, 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 thun. Rashi. In the same way, this nucleus wants to hold on to everyone, the electrons in the atom. But with the increase in the distance between the nucleus and the outermost shell, the force of attraction between the nucleus and the outermost shell, it decreases. And the electrons is like, tu ja. And it will be kind of, the force of attraction, it will be very less compared to the previous shell, and hence the atomic size increases as the force of attraction decreases. Okay? Yes, everyone, you like comedy shows? I don't know, I have stopped watching. My mom used to watch when I was small, and still that serial is running. What was that? Ye Rashi Rasode Mein Kaun Tha? Who is that? I don't know. Yeah. Kya kehta hai? Kya rishta hai? Yes, of course, Aaron. This is for class 10. Okay, so what is happening to the atomic size, children? It increases down the group as the number of shells are increasing. Hence, the force of attraction, the nucleus ka hold on those electrons decreases, and hence there will be increase in the atomic size. Okay, now what about the metallic character? So metallic character is about how easily it can lose electron. So now see, there is nucleus is here and the electron is here. Distance zyada, it is like nucleus is low, don't go electron, don't go. Electron is like, you can't hold me, you're there, I am here, bye bye, it will just go. So that is, with increase in atomic size, obviously the metallic character increases as the nucleus is not able to hold on to those outermost electrons strongly. Yes? Clear? ठीक है? पक्का? साथ निभाना साथिया. No. That's साथ निभाना साथिया. I don't know. So this is with the two properties. One is atomic size and metallic character. It increases down the group as it is increasing down the group. So obviously across the period what should happen? Oops, he fell down. Achha, it's Amy is he. So atomic size, it decreases across the period. Metallic character also decreases because what happens? The electrons are being added to the same shell. Effective nuclear charge increases because the number of protons are also increasing. So that number of protons, it can hold on to the more electrons. It is just pulling the electrons towards itself, leading to the decrease in the size. So atomic size across the period, it decreases as the electrons are added to the same shell, and because of the higher effective nuclear charge, the atomic size decreases across the period. And now this nucleus is holding on to the electrons so tightly, which it is not able to lose. So what is happening to the metallic character? That also decreases. Yes? Got it? Yes? Why did Amy fell? Okay, masked guy, he pushed her. Yes, bichara. So this is our first two properties. Atomic size and metallic character, they increase down the group and decreases across the period. Okay? Yes, very good. So atomic radius increases down the group, atomic radius decreases across the period, metallic character increases down the group, metallic character decreases across the period. Very good. So Amy, tata bye bye. Now comes Einstein. He's like, let me teach you another three properties. So what are those? We have electronegativity, ionization enthalpy, and non-metallic character. Let's see what Einstein has to say. But why has he jumped to chemistry from physics? I don't know. Let's see. Hello. So he will be teaching us about electronegativity, ionization enthalpy, and non-metallic character. So what is this electronegativity? Let's see. Okay. Have you ever wondered, HCl is a covalent compound, but still whenever we add this to water, ma'am says it is dissociating to form H plus Cl minus. We thought covalent compounds does not dissociate. Hai na? Right? Yes or no? Yes or no? Hey, mask guy, yes, I remember. Yes or no? Hai na? Yes. So, but what is the difference? Because covalent compounds, there will be sharing of electrons. There is no formation of ions only. They are aram se sharing electrons and they are chilling. How did this H plus and Cl minus come from? So what happens when the two or more elements with different electronegativities combine? Now what is this electronegativity? So this chlorine is like, hey, I have more electronegativity. Give the electrons. It will try to pull the shared pair of electrons towards itself in a covalent compound. Okay, first the shared pair of electrons will be in the middle, but this chlorine is like it acts superior. There will be people, no? Why are you holding it? Give it to me. So it will try to pull the electrons towards itself, as the electrons are nearer to chlorine than hydrogen. So it will attain a delta negative charge and hydrogen will have delta positive charge. That is because of the difference in their electronegativities. And this property of an atom to attract a shared pair of electrons. Okay, there is formation of a bond. So egg bond means 2 electrons, right? So that is being pulled by one of the atom in the compound. So that is what is known as electronegativity. So you have metals, non-metals. Who likes to gain electrons? Non-metals or metals? You tell me. Non-metals or Bhumi, why do we call this as delta? Because it's not like the chlorine has gained the electron. It is just nearer to it. That's all. Okay. Yes. Very tough definition. What happened? You have a Hanji. Yes. So tendency of an atom to attract a shared pair of electrons towards itself is what is known as electronegativity. And we all know how metals wants to give electrons, whereas the non-metals wants to gain electrons. So obviously electronegativity will have. Let's see, let's hear that from Einstein. Okay. So next definition is ionization enthalpy. We all say na, helium से 2 electrons निकालो और helium 2 plus बनेगा. Sodium lost an electron Na+. It is not that easy. Okay, just like in words we make it, it's just everything sounds very easy. Just to remove 2 electrons, man, that's all. You have alpha particle. But in order to remove an electron from the outermost shell of a gaseous atom, you require some energy. And that is what is known as ionization enthalpy. Okay, so the minimum amount of energy required to remove an electron from an isolated gaseous atom in its ground state. So that is what is ionization enthalpy. It is the same now everywhere. If you have to, like, in the tug war and all that, if you want to pull that team towards the borderline, obviously what you are doing? You are applying energy, right? In the same way, if you have to remove an electron from the outermost shell, as there is this force of attraction existing between nucleus and electron, right? So nucleus is like, no, I won't give, here's my electron. In order to remove that electron from the outermost shell, leave about the inner shells, outermost shell, you should apply some energy, and that is what is known as ionization enthalpy. Okay, whenever we define Shreya, we always consider gaseous atom, that too isolated, because we do not want it to be in the crystalline state and all that. We don't want it to be in a crystal lattice or combined with another atom or in a molecule state. No. Whenever we define, we always take this very standard conditions, that there might be few changes, but that will be the standard. Okay, so this is how we define ionization enthalpy, the minimum amount of energy required to remove an electron from an isolated gaseous atom. So I'm only talking about nitrogen now. It is an atom, isolated atom in its gaseous state. So what is the amount of energy required? Because whenever it is in combined state or in another state, the force of attraction might vary, the conditions might change, right? Because ionization enthalpy, it has a certain value which you will be learning in the higher grades. Okay? Okay, yes Aruna, it is very important. Okay, yes, chalo. So next one is non-metallic character. So metallic character mein the metals give electrons. In non-metallic character, the tendency of an atom to accept electrons is what is known as non-metallic character. They are ulta. Metallic character, the tendency to lose electrons, whereas non-metallic character is the tendency to accept an electron. Yes, it is necessary. It is very important. So now Einstein likes to do a headstand. Imagine there is a photo of Einstein here doing headstand. Can you all do it? Yes, we will just discuss the variation and then we'll go to the Menti. Okay. So that is this electronegativity, ionization enthalpy, non-metallic character, they all decrease down the group. They all decreases down the group, that is electronegativity, because what happens is with the increase in atomic size, okay, with the increase in atomic size, gaining an electron will be very difficult because nucleus is there, the outermost shell is here. If I throw something, right, catch, there has to be someone to catch it, na? In the same way, when I'm trying to add an electron to the outermost shell, the nucleus should be close enough to hold that electron. But with the increase in atomic size, the distance between the nucleus and the outermost shell also increases. Hence, the non-metallic character decreases across, down the group. And even ionization enthalpy, the energy required will be very small. Why? Because the electron and nucleus के बीच का distance ज़्यादा है. If you just take it, the nucleus won't even know. Right? So that is the reason electronegativity, ionization enthalpy and non-metallic character, it decreases down the group, and what happens across the period, any guesses? Very difficult it is. Very difficult. So, oops, he fell down. So, the electronegativity, ionization enthalpy and the non-metallic character, it increases across the period. So you have non-metals on the right side, right? Obviously, the non-metallic character will increase and the ionization enthalpy will also increase because of the decrease in the size. The nucleus and electron ke beech mein distance is very less. So nucleus is holding on to those electrons very strongly. If you have to take it out, you need to apply more energy. And even in electronegativity, so as it cannot lose an electron, it wants to just get those electrons towards itself. So electronegativity, ionization enthalpy and non-metallic character, it increases across the period. Yes? Okay. So I hope it is clear. Now we'll start the Menti, everyone. So go to the same link. Go to the same link. Now let me just see if it is ready. Okay, it is. Suhita, whenever it comes to D block elements, you cannot say anything. So that is the reason I am coming up with a session next week to talk about this weird properties or abnormal electronic configuration of D block elements. In that we will be talking about all this. Ready? What happened? What happened? What happened? Pranav. I'm so sorry. I couldn't see. I couldn't see. Priyanshu on the platform? Yes, yes. Come on, people. Please join. Vedantu live session is also there. Hanji. Even I have a session. But make sure to hit the like button. Come on, people. We should cross 100 likes now. Fast, fast, fast. I can't see the doubt. I don't know. Even I'm like just going up to Pranav. Can you send it again? Of other atom. See, you know what is happening is it's not about attraction and all that. So there exists, there will be repulsion between two protons. There will be repulsion between two electrons. There will be force of attraction. We are just comparing. It is all about the relative attraction. Okay? Yes. Like after Menti. Starting. Shall we start? Okay, question number 3. All the best, everyone. All the best. Yes. So even after this, if you have any doubts, let me know in the comment section. And if you have any other super tricks using which your friends can also learn the periodic trends easily, do let us know. The energy required to remove an electron from an isolated gaseous atom is called. Come on, come on, come on, everyone. 3, 2, 1. Aw, Pranav, I always try to. Whoa. 79% of you gave the right answer. Kya baat hai? You are doing well. Okay, did you ask me? I'm also doing good. B for bonds. Chemical bond. Okay, so on the leaderboard we have, let's see. बी 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 बी, हाँ हो गया. श्रेया, हरी, सुची, अरीन, मित्तल, खुशी, रियाज, आराधना. Last among is warning. Manaswini. Okay. So question number 4. Let's see. Which amongst the following elements will have the highest metallic character? You have magnesium, carbon, silicon, sodium. See what happens to the metallic character across the period, down the group. So you have magnesium, carbon, silicon and sodium. Hello everyone. Hello. So if you have not joined the Menti, please go to www.menti.com and use the code 10360562. See, where is sodium? Where is magnesium? Across the period, na? Sodium is in group 1, magnesium is in group 2. So across the period, what is happening to the metallic character? It is decreasing. Carbon, silicon, to chhod do, they are there. Right? So metallic character will be highest in case of sodium. Right? Please do not get confused. ठीक है? Okay, chal. Next one. So on the leaderboard we have Sriya, Hari, Areen, Riyaz, Aradhana, Suraj, Suchi, Mittal, Manaswini, Khushi. Okay. So next question is, let's see, question number 5. Are you all ready? And for all the students who have not joined the Menti, please go to www.menti.com and use the code 10360562 as we still have 3 questions. So lithium, sodium, potassium. Sriya, when I say metallic character, it's only about with what ease an atom can lose electron or gain electron. Metals, they will have more metallic character. Obviously, the elements which with more positivity or the tendency to lose electron, so they are considered as metals, right? Yes. Whoa. So it is lithium, sodium, potassium. Down the group, what happens to the atomic size? It increases. So among these 3, lithium will have the smallest atomic size. Yes, got it everyone? No confusions? Chalo. Okay. No Suraj, I will call you Suraj only. Hello sir. Okay, I don't know why. What is the confusion? Huh? On the leaderboard we have Sriya, Areen, Riyaz, Hari, Suchi, Mittal, Manaswini, Tejeswari, Aradhana, Suraj. Ah, very good. Why? It's okay, Kirti. Question number 6. Are you ready, everyone? Ready? Okay. How many valence electrons does potassium have? That's okay, Doraemon. Why? See, that is the reason. Please click on the bell icon so that you will know when we are coming live. How many valence electrons does potassium have? Write down the electronic configuration. 4. What is the atomic number of potassium? 19, right? So 2881 it is. It has 1 electron in its valence shell. So option C is the right answer. So almost 69% of you gave the right answer. Very good. Whoa. That's nice. Come on, give me a high five. Good job, everyone. Good job. Okay. Wait. We still have one more question. So on the leaderboard we have Sriya, Areen, Riyaz, Suchi, Hari, Suraj, Goranj. No more student suicide. That's really nice. Akshay, Mittal, Manaswini. Oh, yay! Last question. Ready? Pakka. How many of you think you can answer this right? Tell me fast. Pakka, ma'am. Right answer. Then I'll give a dare to Dibu ma'am. Okay, next her class is then at 4. Okay, me pakka? Okay, let's see. Yeah? Dibu ma'am, this is for you. Who helped you in learning these trends? My name is there. Arey, they should have added Surabhi also, no? Who is Ron? Amy Einstein, Ron, both Amy and Einstein. Wow, wow, wow. Both, right? We used both of them helped us. Both Amy and Einstein, right? Well. So option D is the right answer. You people lost. Or not even 70%. क्या है जी? क्या है जी? Yes, so we will look at the leaderboard, but before that, everyone, let me remind you. So today my micro course is starting. How to score 100% in chemistry for all the CBSE grade 10 students. It is at 6:15 today, where I'll be teaching you some tips and tricks and important books to refer and the previous year question papers. Everything will be solved in that. She's actually taking 3, and all the teachers out there on YouTube, they will be taking micro courses this month, which will be very, very helpful. For that, what you have to do is visit the link given in the description, because of course we will try to cover everything, and now our channel has become grade independent. Few will be confused, ma'am, this is for 10th, this is for 9th. So we will cover the entire syllabus of grade 9, 10 on our platform. ICSE, CBSE, Maharashtra board, all. So the Vyasha ma'am will be taking Maharashtra board. I am taking so many batches for class 9 and class 10 this year. So all you have to do is visit the link which is given in the description and use the coupon code SURPRO so that you will get 10%. Shh, don't tell this to anyone. It's only for you. Okay? So if you are wondering why should I take it? Will there be improvement? We guarantee you that there will be improvement in your performance. What if there is not? Then you will get your course fee back. So we have, for the first time, we have any edtech company has come up with Vedantu improvement promise. So you will know the trust we all have in ourselves and the entire team. Because if any one of you feel like there is no improvement in your performance, you will get the course fee back without any questions. So why should you join? Again, it's a one-stop solution for all your problems. Because few will have problems with notes, and few are like, ma'am, my doubts are not getting solved. Hai? So here also you have to write it in the Google form and then wait for a different session where your doubts will be cleared. But there, when during the live session, we will have master teachers and class teachers who will make sure to resolve all your doubts. So I have shown you the session replay as well, right? Where you can watch the replay, where you can get the notes. And if you see, out of 100 doubts, more than 99, around 99 doubts will be solved usually. You will be able to compete with the students all over the world, so which is very, very important, which will give you an idea about where you stand. So, okay, this is where I am. How can I improve? Where should I work more? So that is very, very important, because if you just try to just compare yourself with few of your classmates when you are trying to attempt the competitive exam, you will have no idea who are your competitors, right? So this will also help you a lot. Now I have already told you, in case you have not attended the session, you couldn't for some reason, you can always go back and watch the replay. You can play the quiz as well, which is not possible here, right? Once Menti is, no, we are late, we can't play Menti. But there, every single day, every session where you can play the quiz, you can be on the leaderboard as well. After every session, you will get the notes. Assignments will be shared with you, which is very, very important, so that you will practice a lot and you will know how to write in the exam. So tests will be conducted topic wise, chapter wise, which is also very, very important. And once you are a pro subscriber, leave about long term. You're only taking the pro subscription for long term, right? But what about the micro courses? Free unlimited micro courses. So if you divide whatever you are paying by the number of sessions, including micro course, it will be very, very, very less. So that is the reason only here less is more, because if you take more classes, if you attend more classes, the lesser price you will be paying. So all you have to do is visit the link which is given in the description and in the pinned comment. Use the coupon code SURPRO and remember the micro course for today. Yay! It's akka. Okay. So we have different kinds of plants, that is pro, Light, Pro Classic, Pro Plus. So you will be getting everything except doubt solving on mobile app and personal mentor, which is only available on Pro Plus and Pro Classic. But according to me, Pro Lite is enough, because even the amount which you will be paying is less. You will be getting offer also. If you use the coupon code SURPRO, you can pay it through EMI as well. So if you are still doubting will that be useful or not, then you can just try it for 1 month. If you like it, you can continue it. But we bet you are gonna love it, because there are so many students who have joined us and they are very happy with what they are getting in return. So all you have to do is visit the link given in the description and use the coupon code SURPRO. So now let me show you the leaderboard for today's session. And come on, hit the like button, everyone. We said we will make 100 likes now today. Are, it's okay, Niyati, it's okay. So on the leaderboard we have Sriya, Suchi, Areen, Riya, Suraj, Gauransh, Manaswini, Akshay, Tejaswari, Aradhana. I'm taking a screenshot. We will put it on our community. So congratulations to each and everyone who attended the session. I'm sure you learned a lot. So let me know in the comment section, how was the session? What was your favorite moment? And do you have any tricks to master the periodic trend? So thank you so much. You can see this thing, right? Yes. Bye bye everyone. Take care and make sure to hit the like button. Come on. That's okay. That's okay. As long as you learn something, that's all matters. Okay? Bye bye everyone. Take care. See you. See you tomorrow. And let me know in the comment section. Okay? I'll be waiting.